Welcome. Let's go over day 19 linen layout of Advent of Code 2024. For this first part, they want us to, given these what they call patterns, if we can somehow construct them in some order, that would yield what they call designs. So it doesn't matter the order or anything. They just want to know if it's possible, and if it is, count the number that are and return that. So for this test, there are six. For this test data, there are six of them. Out of the, I think there are eight. 2, 4, 6, maybe not. 8, yeah. 2, 4, yeah. Six out of the 8 are possible. And so what I'll be using is recursion and backtracking. So it shouldn't be too bad. Let me just start this over. Yeah, let me just start it over so you can. I was doing this a while ago and it, for some reason, Safari crashed. So I don't know why. Okay, so let's start off with the opening the data. So the data consists of a single line that has all the what they call patterns. So let's load that. So we'll call this so we'll do with open test 19.text read as f, and we'll read that. So f dot read line dot strip. So strip the new line, and then we'll split it. Because if you notice, they're all separated by a comma and a space. So we'll do that here. And what I'm going to do is a little bit of my approach is to use backtracking. So what I'll first do, I'll say, okay, I want to try matching one letter. So I'll look through these and say which one of these is of length 1. Then if that doesn't work, I'll check the 2-letter ones. So I'll check WR and RB and BR. Then if that doesn't work, we'll check the 3-letter ones and use the 3-letter ones. So it'll be helpful if we store these patterns by their length, or we categorize them by their length. So let's do that. So we'll say something like, so I'll call this patterns. Patterns equals, I think, get default dict. Let's see. Then we'll be storing it by, and then it'll be, let's see what's going on here. So for pattern in this, we'll say patterns length of p equals p. No, dot add dot append p. So what we're doing here is that this will be a list. Okay. And then we'll print this out shortly so we can see what's going on there. And then we'll need to read a line and skip it. So f.read line. Because they give an empty space here. Sorry, an empty line. And now we'll read all of these and just add it to our designs. So designs will just be a list. Designs just be list. And then we'll loop through them. So for line in f, line dot strip, and then we'll say designs dot append that, and then let's print it out so we can see it. Print f patterns. Okay, let's print it out. Okay, so patterns, notice how the key is 1 and then it has the single value patterns. Here's the key is 2, and then all the 2-length patterns and so on and so forth. And designs is just that. So it's a string. Nothing too amazing there. Now let's continue on. So what do we want to do? We want to look through all the designs. So for D in designs, and we want to check if, well, let's get, maybe we'll call this count equals 0. And we'll say if, I'll call it backtrack D. So if we find that design, then we'll say count plus equals 1, and then at the end we'll just print it out. So print f count. Okay, so now let's define backtrack. We don't need these anymore. Define backtrack. What I'm going to do is, in order to speed this up, it may be advantageous to incorporate caching. So let's bring in caching. So from func tools import cache. So this means, like, for example, suppose this is just an example. Suppose we pass in, I don't know, we pass in what do you want to do? WRR. Are there any ones that have I'm looking for repeats. BBR. Okay, here. Cool. BBR. Suppose we check the first letter G, and then we're on to BBR. So we find BBR. So when we get to level 10, we can use that to our advantage. So our toString to this line 10 here. Notice how this BBR is the same as this BBR. So that's where this caching becomes valuable, or and can be useful, is that we don't check it again because we know it's already there. So it can make our processing quicker, because it'll say to itself, hey, I saw this pattern before. We don't need to continue. We can just return the value from the previous result. Okay, I hope that makes sense. If not, add a comment and I'll explain it again. So anytime we use recursion, we want a base case. So if s equals the empty string, we'll just return true. That means it's valid. Otherwise, we'll say we'll loop through the string. So we'll say for I in length and range length of s. Okay, so this will be, imagine the first letter. So we're going to check if B is found, then R. We're always going to grow, check how far we need to go. So we'll say if backtrack. Now we want to start, so S of the next one. So we'll say I plus 1. So first we want to check, is there something in here that matches it? So we want to check, well, we'll look in our patterns. So we'll say, and remember, patterns is a dictionary with the length of it. So we'll say, okay, for what do we look at? So patterns. Now, which patterns do we want? So this is the first letter. So remember, we're going letter by letter. So we're going to start here at, this would be 1, then 2, then 3, and 4, then 5. 4, then 5. So the way this works, though, it'll be 0. So in order to do what we want it to do, we'll say I plus 1. So remember, this will start at 0, but we don't have any patterns of length 0. It wouldn't make sense. So we'll add a 1 to it. And then we say, okay, for the pattern and patterns. So we'll say for P in this. So remember, patterns has all of the patterns with length 1. Remember, I don't, if I showed you earlier. Where is it? I wonder if I can still. Okay, it's not. Well, if you recall from earlier that I showed you that, because I don't want to go through that again. But just remember, patterns has the. Let's just print it out. It's fine. Let's comment this out for the moment. Let's comment this out for the moment. And let's print out patterns again. Print patterns. Let's go down here. Let's run this. So remember, this dict at 1 has all the patterns that are length 1. Pattern dict at value 2 or key 2 has a list of all the patterns of length 2 and so on and so forth. So we can use it here. We'll use it right here. So bam, 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 bam. So we'll say, okay, so there's a pattern that matches it, so we can use it. So we'll say, okay, we're gonna peel you off. So backtrack. So we're gonna pass in the string starting there. So starting at what is it, s of I plus 1 to the end. Okay, and then if this is true, so if backtrack is true, then we'll say we'll return true. Otherwise, we'll return false. So as you can see, first we'll try all the patterns. Wait, sorry, what did I do wrong here? Sorry, I have to check if they match a pattern. Sorry. Let's do this. Sorry. If P equals this guy, the front, S of I plus 1. And this is just a little trick I'm going to do. So if there's a pattern that matches the first part, we're going to move on with the second part. So if, for example, I think I showed this earlier, if B and B match, then we're going to move on to the next recursion level or depth with R, W, R, R. And then if R matches, then we're going to move on to WR. That's how this will be working. So going back over here, so if the pattern matches, then we move on to the next level of this backtracking of the recursive function. And then if it returns true, then well, we return true also. And otherwise, we just return false. And I think that's it. Okay, let's run it and let's see what we get. I think for this first example, so this is running for test. And I think for this first one, the answer was 6. So hopefully we get 6 here. So we get 6, great. And then it's the same thing for the real data. Okay, and for part two, they ask us, now they don't want to know, they say something like they don't like the way we, ordered the letters, the patterns to make this design. They want to know all the different ways you can make up a design. So for example, this, well, let's use this here. So GBBR can be made 4 different ways, and they just want to know in total how many different ways can you make all of the designs. So that isn't too bad. So let's go back to our code, and I'm gonna actually just, it's very similar, but I don't want to like ruin that. So we'll just make another backtracking function, and now instead of returning true or false, we'll return, in this case it will return 1, because if we make it to the end, we know there's one way for sure. And let's adjust this here. We'll call this count equals, we'll call it count equals 0, and we'll return count here. So in this case now, if there's a match, I'm gonna do a little bit different this time. I'm gonna say, okay, I'm gonna say count plus equals that. So let's go over that here. So we're gonna go through every pattern, and if there's a match, we're gonna move forward. And now we're just gonna keep counting. And then so remember, this is first starting off with length 1, and then we'll start off with length 2 for the pattern, and length 3 and length 4. Just so we get a chance to exhaust all pattern options and all pattern combinations. Okay. If I didn't mention this earlier, they mentioned that there's an unlimited, I think it's somewhere in here. Let me see, unlimited. Yeah, here it is. So we have an unlimited amount of of these patterns that we can use. So we can just use as many as we want. So um, I guess that was important, and I apologize for that. I apologize for not mentioning it sooner. I do need to adjust this here. Okay. Now what else? Anything else I need to change it? So this is all good now. Now I just need to change this part here. So it's kind of modify it really quickly, and we'll call this maybe total. Maybe total. And now we're using backtrack 2. That's right. So sorry, this is a little bit different. So now we're returning the count. So we'll say total plus equals that. Yeah, so backtrack 2 returns a count, and either returns 0 or didn't find it, or it returns some number. Okay, let's try it out. Let's save it and run it. So I think for this problem, the answer was, for part 2, the test data showed 16. So let's try this here. Okay, great. So that was it. There wasn't, I thought it was rather straightforward. I thought it was one of the easier ones, but again, like easy and difficult and hard is all subjective or relative for every individual. So in any case, I didn't think it was too bad. But if you have any questions, let me know. If you felt this video was in any way educational or helpful, please consider liking or subscribing. Other than that, have a wonderful day. Take care.